Hi guys, just got my hands on the multiple choice for exam 2, so I thought I'd quickly see if I can go through it. Um, this first one, I haven't looked at any of this yet. We know that our period is 2 pi on n, which in this case n is 2, so it's just pi. Got to be careful because they give you tricky ones with this. The horizontal asymptote is going to be the bit that's added on, so it's going to be y is equal to 4. The gradient of the graph, the point where it crosses the vertical axis is, geez, that's a bit easy. dy dx is 3e to the 3x. Vertical axis, x equals 0. So you know that's 3e to the 0, which is just 3. Which of the following is not continuous over that interval? Okay, so that's continuous because it's only not continuous at negative 3. That's continuous because it goes from negative 3 to infinity. X to the power of 1/3, well, that's also continuous. Tan of x on 3 means that my period would be pi on 1/3, which is 6 pi. So my first asymptote would be 3 pi, which is greater than 5, so that's also continuous. Sine squared x on 3 from 0 to 5. Sine x on, I don't know why this isn't going to be continuous. Squared. Tan x on 3. Oh, how did I stuff that up? Well, we know it's tan x on 3 anyway. The largest value of that function, where f is 1 to 1, so it's going to be the turning point, which is negative b on 2a. So that's negative 3 on 2, negative 1.5. Which of the following are not inverse functions? X squared on the left, root x on the right. What's that one? Because we're doing the left-hand side of that graph, so that should be negative root x. Let's have a quick look. Here, we would get x minus 3 on 5, so they're the same. Here, if we brought that to the other side, we'd get x minus 2 times 3 divided by 2. So we get 3x on 2 minus 3. Yeah, that's an inverse. Yeah, that's it. Okay, log of x plus 1, I'd get x minus 1 e to the, yeah, that's the right-hand side. That's right. Okay, the graph of that, the graph of f dash of x, the first derivative of that could be positive gradient, so it's got to be above. Negative gradient, it's got to go below to there. And then positive gradient above. So the only one that sort of looks like that is E. Okay, this one here, A is between 0 and B. Okay, so if I want A to B, that's the same as A to 0 plus 0 to B. We know A to 0 is the same as the negative of that. So we know this is positive 4, and that's positive 10, so that's got to be 14. Does that make sense? A to 0 plus 0 to B. Hmm. That makes sense. The shortest distance from the origin to the point xy in the graph of f is given by, okay, so we know we've got that minus the origin squared, so 2x plus 1 squared, plus x minus 0 squared, x squared, which we know is 4x squared, plus 4x plus 1 plus x squared. The shortest distance is given by, okay, so that's 5x squared. The shortest distance is given by, so if we go from there, the shortest distance is going to be there. If we let x equal 0, we know we get 1. That's a strange question. Shortest distance from D, from the origin to the point xy, on the graph of f is given by. So our distance, we know, is that function. So if I say the square root of 2x plus 1 square rooted squared, so we just get 2x plus 1, plus x squared, you get the square root of x plus 1 squared, which is D. But that's weird. So it's whatever that x value is, that x value plus 1. Okay, 55% of those are happy, 95% are happy with the level of physical activity is closest to 95. So 55%, 550 out of 1,000. And we want a 95% confidence interval. So 1 prop z int, 95, 550 out of 1,000, 0.519 for the percentage. 51.92, 58.51.92. Okay, the derivative of x sine x is equal to that, then x cos x. So we know when we derive that, we get this. We want to antidiff that by itself. So we know 1 on k, x cos x dx is the same as 1 on k, the d dx of x sine x. And then when we bring that to the side, we get minus sine x dx. Okay, so we know this, when we antidiff it, is just x sine x. So we get 1 on k x sine x minus the integral of 1 on k sine x dx. We could put that 1 on k right out the front. So x sine x, so 1 on k x sine x minus sine x dx. So I get C. If we antidiff that, we get cos, so it can't be anything else. Okay, bag needs 3 pens, X black pens, 2 pens are randomly drawn from the bag of that. I'm probably drawing a pen of each color. is equal to 3 red pens, x black pens. So 3 red pens. So I could go red, black, black, red. Red, we've got a 3 on x plus 3. And then black, we know we've taken 1 pen out, so it's going to be x plus 2. And the number of black pens is the total amount minus 1. The total amount is x plus 3. Is that right? Oh, hang on. It's the number of black pens left, which is x. So 3 over that, x over a reduced number by 1. We could get a black pen, which is x over x plus 3, times a red pen, which is 3 over x plus 2. 3x plus 3x is 6x. So we end up with 6x on x plus 2, x plus 3. This has a maximal domain. X plus a over x minus a has to be greater than 0. If we use long division, x plus a over x minus a, transformation, part frac, 2a minus 1 plus 1, 2a x minus a plus 1. Now, if we want that to be greater than 0, we know we've got a horizontal asymptote at 1 and a vertical asymptote at, is a is positive, at a. So if I let this thing, if I let it equal 0 to find my x-intercept, we get negative 1. 2a on x minus a is equal to negative 1. When we switch those two, we get negative 2a is equal to x minus a. So we get x is equal to negative a. So it's negative a backwards, and then a to infinity. So all real numbers, but we can't include anything between negative a and a. The expected value, so we just multiply that by x and anti-diff it. So 2x squared, 2x squared times 2 on 9 times e to the negative x squared on 9, x times the function. The integral of that between 0 and infinity dx, 2.658, 2.659. Just thinking we just multiply x times f of x, yep. Okay, now the maximal domain of that function is given by x minus 3, x plus 1 has to be greater than or equal to 0, because we can have 0. So 3 to negative 1, it's going to go that way and that way. So negative infinity to negative 1, or 3 to infinity. Okay, as turning points at x are going to pass us through the point 3, 4. The values of m, n, and p respectively. Okay, 1/3 x cubed 1 on 3 x cubed plus m times x squared plus nx plus p. Define that as f of x, derive it, define that as g of x, and then we know we can use simultaneous equations. We know g of something equals 0, and then the same thing again. I think it's -3 and 1. And we know f of 3 equals 4. And we want to solve for m and p. 1, -3, -5. -5. Okay, function D is continuous on the domain from A to B and has the average rate of change between A and B is positive. So just say there's A, there's B, in between there, it's got to be going upwards. The instantaneous rate of change of G at x equals A on B, so that halfway mark is negative. So it's got to go down because that's negative, and then it's got to come back up. So it's not strictly decreasing or increasing. 1 many to 1. Many x values give the same y value. X is a binomial random variable. Okay. Probability x is greater than something equal to that, then A is equal to. Okay. I guess you could just use trial and error. That's got to be less than that. Probability. So we could just do, I just can't be bothered trying to work it any other way. Binom CDF, 16 to 20, 20 and 0.88. We get that. If we divide it by 15.949175. So let's go 12, 11, 12, 12. I mean, that's pretty easy if you just play around with it. 13. Yep. Okay, a box is formed which has widths of 8 and lengths of b units. By first counting squares of A and then folding upwards to form the maximum volume of this box will occur A minus 2x, A B minus 2x, and then x. So x times A minus 2x, B minus 2x. Does it have a restriction? So we could say, oops, we could go f max between 0 and A. Probably easiest to diff that. set it equal to 0, and solve. Okay, which one's a maximum, which one's a minimum? What do we know? We know it's a positive cubic, so it's got to go like that, which means the maximum occurs at the negative value, because it's got to occur to the left. So we know it's got to be that value, which is a plus b minus. What's the difference between these two? We don't want the 2ab, we just want the ab. Okay, a soccer player kicks a ball at an angle of elevation of 0 degrees, where theta is normally distributed with a random variable of a mean of 42 and a standard deviation of the horizontal. The probability that ball travels more than 40. What the hell is this? So the distance is given by that. This is kind of like a special question, like a linear combination. The probability that the ball travels more than 40. So if I said 50 sine 2 theta equals 40, we know it's going to be between, say, 0 and 100. What is this? 50 sine 2 theta, where it's in degrees. So if it's 26 degrees, if I put 26 degrees in there, 26.56, we get 40 meters. So we want to use norm CDF from 26 point something to infinity, 8 and 42. So 26.56 goes in there. 0.9713. 9731. Ball travels before that the ball travels before landing is given more than 40 meters before landing. So if it's got to equal 40, it has to be released at an angle greater than 26.565. That kind of doesn't make sense. I mean, if you've got this curve, that's 42, That's the angle that it's released at, 26.56. Sine 2 theta. Let's go 50 sine 2x. Zoom out. Zoom out. Zoom. Okay. X-intercept. Actually, let's say, where's 40? D-sol intersection. 26.565 to 63.435. 26.565 to 63.435. 0.969. That's different. That actually hurt my brain a little bit, but oh well. Hopefully I have done them all right. My brain's a little bit mushy at the moment. But I don't think this one's a bit dodgy. The shortest distance d from the origin. That's just, I don't know why they're saying the shortest distance. Like, the distance from the origin is that. Is that right? So if I get 2x plus 1 square rooted and squared plus x squared square rooted, that's the distance from the origin. We know that's 2x plus 1 plus x squared, which is x plus 1 squared and square rooted. The shortest distance, you would differentiate it and set it equal to 0. That's just the distance. So I don't understand that question. That's right, that's wrong. I think everything else is right. Anyway, have a look at it, see what you think. Let me know if you think something's wrong. I'll try and fix it up later. Bye.